Are we doing what they did here?
That's what I did. All right, so now that we have midpoints marked, we have the ability to create mid-segments. So using your ruler to create a mid-segment, you would just connect midpoint to midpoint.
Yay.
So take your ruler and go from midpoint to midpoint. Using your ruler, go from midpoint to midpoint. And using your ruler, go from midpoint to midpoint. So you should have 3 mid-segments.
You made a fourth triangle.
But wait.
If you color in the middle one, it's something.
You did more than 4.
Oh, you're right. We made 5.
All right, so
Yeah, you're right.
now to really solidify this, like midpoint to midpoint, right? Now the fun part is, did anybody measure how long BC was?
Yes.
What'd you get? 20.
That means.
Now the cool thing that's going to happen is measure this one,
It should be 10.
the one that's parallel. Measure it.
I'm sure yesterday.
It's funny how learning happens like that, right?
Same.
Pretty close to 10. Now, is that a mistake or is it supposed to happen that way? Supposed to happen that way. So let's verify it on this side. How long was AC when you measured it?
14.
So y'all measured 14 there. And then,
7.
did you measure it though?
Yeah, I measured.
You measured it and got 7. So it happened again. And then, how long was AB?
8.
It's just half. That's weird. But wait, there's still more. There's still more. So, think about this concept. What is Z?
Oh wait, no.
It doesn't matter. Or
10.
what is this point?
10.
No, what is the point?
10.
No. What is the point? It's called a midpoint. So if this whole piece is 20 and this is the midpoint, how long is this side? 10. And how long is this side? Because it cuts the line in half. Now, if AC is 14 and Y is the midpoint, how long is AY? How long is YC? And if AB is 16 and X is the midpoint, how long is BX? Now that's where the really fun stuff happens. You see the triangle in the middle was a 10, 8, 7 triangle, and this triangle is a 10, 8, 7 triangle. And this triangle is a 10, 8, 7 triangle. And this triangle is a 10, 8, 7 triangle. It creates 4 congruent triangles by the SSS postulate. Remember that shortcut thing?
Yup.
Yes.
What if we drew 4 triangles?
So if you look, it's a good conversation to have. If you continue,
We just keep dividing by 2, right?
if you continue the midpoint pattern, it creates this thing called Sierpinski's triangle. And I'll let you Google that later. What Sierpinski's triangle looks
How do you
like.
spell that?
Should we Google it together?
Yeah, I'll pull up my phone.
Yes, we should start.
That's pretty cool.
Yes, that's right. It's a triangle top.
So
Find a GIF of the Sierpinski triangle.
Sierpinski's triangle is the application of multiple midsegments upon multiple midsegments. If you really get deep into that concept, it's called a fractal, where it's a pattern that repeats on itself over and over and over again. You're like, God, this is just boring math, right? So this is a fractal down here. And like, does that even matter to you?
No.
Who likes the
Well,
movie?
at some point.
Who likes the movie Star Wars? Yeah. So the whole point behind fractals is how they created the lava behind the fight scene. They used a fractal math to create the lava effect. So they use mathematical fractals to create special effects. Okay. Now, so we've done the majority of the math here, but we've missed one key concept. How would you describe this green line right here and this black line right here? Parallel. So they have two different mathematical properties. Number one, that the midsegment is half the length of its parallel side. And the other two things are these are parallel lines. So let's jump into our notes real quick. We've done a lot of the legwork. Let's just kind of solidify a couple of different techniques. So open your notes. It says, what is the midpoint of AB? What is the midpoint of line segment AB? X. And what is the midsegment of line BC? Y. So that line segment XY is now called what? A mid-segment. So if you can't remember that, I would write that in big letters across that triangle that you just played with. Mid-segment. You'll see I did that up here. I labeled this as a mid-segment construction. So on this triangle, write in big, pretty letters, mid-segment. On this triangle, write mid-segment. Kaden, mid-segment on that big triangle. Okay? So, then we get to the properties of mid-segments. A mid-segment is parallel to the third side. And a mid-segment is half the length of the third side. Now I keep saying that thing, the third side, the third side. Which one's the third side? Yeah, that's just kind of repeating the definition, but does that make it clear for everybody? So like if this is the mid-segment, which one's the third side? The side that it's not touching. That's kind of the default definition I go to. So you can see what it looks like, right? But kind of like a generic student definition is the side that it's not touching. So that's all the laying the foundation stuff. Now we get into the actual mathematical application part, right? So you'll see a couple of these questions in your quiz and your test. It says AB is a mid-segment. We're on the next page, so go ahead and flip your paper over. It says AB is a mid-segment. So what is the value of X?
5.
Okay, can you explain how you got there?
I just did it mentally.
And that's not always going to work. And there are some people that don't know how you got 5. If this piece is 20, then how long is this piece?
10.
That's where we need to be, right? The third side is 20. So the short side, or the mid-segment, is 10. That creates an expression we can't solve.
I know how we got 5.
And now, what do you do to solve for x?
Well, 2x is the line minus 10. 2 times 5 is 10.
So understanding what we're doing, what is the value of x?
5.
But what is the length of the mid-segment?
10.
You see the difference? So I'm going to give you guys a couple layups, some confidence builders to move through this. Alright? These are not quiz questions. These are too easy for quiz questions. But they're a good place to practice. If DE is 15, how long is AC? 30. And how are we doing that? That's called the third side. You multiply the mid-segment by 2 to get to the third side. Does that make sense? How long is the mid-segment, TU?
13.
Yeah.
And so we went the opposite way in this scenario. We divide the third side by 2 to get to the length of the midsegment. So did I lie when I said it was going to be an easy thing?
Yeah,
Right? Let's just celebrate the ease. What is the length of the
5.3.
midsegment? How are you getting there?
Times 5 by 2.
Divide the third side by 2, so 10.6 divided by 2 is 5.3.
Yay.
Yay? Okay, if the third side is 8.8, how long is the midsegment?
4.4.
So you guys are skipping past and not paying attention to the easy ones, that's going to make the harder ones harder for you. Okay, how long is GH if the midsegment is 15? Double it, you get 30.
Yay. Yeah.
If the midsegment is 4.5, how long is the third side?
9.
And then here's the quiz question. So let's all pick our eyes up and look at this one. Can you mental math this one now?
If I try hard enough, yes.
Right, but there is a way.
It
Where
would
there's
take
a
a
will,
lot
there's a
longer,
way.
but yes, I could.
Say what we're saying?
5x plus 7 plus 3x.
No. That doesn't work. So you have the right concept, but you do like everybody does, and you mix the things up. So what were we doing earlier? Like if the midsegment is 3x, how long should it be down here? 3x times 2. We should double the midsegment to get to this length. So what is 3x times 2?
6x.
This is now an equivalency ratio, right? That is where the hard stuff happens.
Well, I know the answer.
The mathematical concept that the midsegment is 3x, double it. It's 6x down here. Now I know these two things are equal to each other. So
X equals 7.
6x is equal to 5x plus 7. If you think about it this way, 2 small pieces equal 1 large piece. That makes sense, right?
Yeah.
You had it backwards where you divided it by
I don't
2.
know why.
No, and it does it to everybody. Everybody does it.
Baker's X7.
Yes, it is, Mikey.
And you're proud of that, right? Because you're exactly correct. But what could I do to say no, you're wrong?
That's not the midpoint, mid-segment.
So I'm going to ask for how long is the mid-segment?
21.
So the mid-segment is 21.
What if you told us we were wrong again?
But how long is the third side?
42.
Can I ask an honest question? Give me an honest answer. How did you get that?
Times
Multiplied by 2.
Now, what happens if when you plug this in, it doesn't equal 42? So it'd be worth your time to actually plug it in.
I did
5
35
times
plus
7 is
7, which would be
plus
I would
2
do
is
a small
42.
brain there.
You see what I'm saying?
Yeah.
Like if you plugged it in and got 10 and you doubled it and got 20, did you really check your work?
No.
Not really. So like you're cheating. It's good that you're checking your work, but don't skip over all that hard work. These guys, this is the quiz question right here. Something that looks like this, where you have to do algebra.
Right triangle.
Algebra.
Is that?
Okay, yeah. Does the fact that it's a right triangle mean anything?
4x plus 10.
No. What's that?
4x plus 10.
So if the midsegment is 2x plus 5, I can double that. So 2x plus 5, or 2 times that would be 4x plus 10, right? Does that kind of make sense? That's 2 small pieces.
Yeah, boss.
And how'd you get 5 minus 3x on both sides?
Yeah, boss.
And subtract 10 from both sides. So x is 5, right?
15.
And 2 times 5 is 10. 10 plus 5 is 15. So the midsegment is 15.
Yeah.
3 times 5 is 15. And 15 plus 15 is 30. And then you look at the relationship. Is 15 times 2 30? Yes. Okay, last one. You ready? Okay. So if the midsegment is 10x, what can you say that the third side is? So if I double the midsegment, it is equal to the third side. Now I have an equivalency.
That means X is, that just tells you X.
And right, that only tells me the value of x. But then I have to use the value of x to find the length of each side. So minus 15x is on both sides.
That's what I was saying.
What's the issue?
I don't know.
So yeah, like it doesn't tell you how long the midsegment is, but what is 10 times 1.3? 13. Now, if this works out to be double, what is 15 times 1.3?
26.
No, you're not doing it right. You're assuming that this is correct.
It's like 19.
15 times 1.3 is 19.5, and 19.5 plus 16
I couldn't calculate it.
didn't work out correctly.
Yes.
So your x value is
I know you don't want
correct.
to assume, but I already entered the calculator, so it's fine.
And most people aren't using calculators today, so I don't expect to do it like that. Alright, and then here's the absolute last thing right here. You ready?
This one's gonna be wrong.
Yeah.
Oh God, no.
I can do it.
So when you guys see this, what do you expect to be asked?
You get the find the midsegment.
Find midpoints.
Finding mid-segments, right? Now, does it remind you of what we did Monday when I said find midpoints?
Yeah.
Sort of.
So the first sentence then, if you're going to create mid-segments, you have to know midpoints. This is on your test.
Can I do it?
So let me slow it down because some people still aren't comfortable with finding midpoints. Because you have two options. The calculate or the count method.
Count.
Counting method. So did that how you did it, Mikey? Counting or did you calculate?
I did both.
So I think counting is easier. So let's kind of solidify what counting looks like. You make a triangle, and we're gonna count up and over. Okay, perfect. I count up 10 and over 6. Now that is how far it is to go from one end to the other. So how do I get to the midpoint exactly in the middle? Do half of that. So what's half of 10? And half of 6. Boom, midpoint.
Can you use the green again?
Okay, let's do green for Caleb.
No, like the top one. Yeah.
Nice.
I like that. 10, 4.
And how did you get 10? Did you count it again?
Yes, I count.
Okay, so you counted 10 here, and you counted 4 here. So that is the distance from one end to the other, up 10 over 4. I did do half of that.
And this one's easy. So the bottom one's easy.
Boom, midpoint.
That's great.
Alright? Now, what about this flat line?
You can just count it.
It's 10, 5,
10, and half of that is
5.
5. So if you did all the work to mark the midpoints, what should you take celebration in?
That you found them.
Actually drawing the mid segments, right? You actually want to do that.
Oh, I guess. You need your straight edge.
Using your ruler.
Your straight edge.
It's called the ruler now, Carlos.
We're not using this as straight edge.
Using your geometric tools. Okay. So, look guys, all of that was just setup math to do the actual question. The question says, what is the equation of the midsegment parallel to BC? Guys, that's a lot of words, isn't it? What is an equation that is parallel to side BC? So side BC is right here. I want to know what is the equation of the midsegment that's parallel to that. So this is the only midsegment I care about. What?
Okay.
He's not doing anything.
Okay, now let's talk about this because this is the test question.
Oh,
Got it? And that's half of it, right? Identifying the correct midsegment. So what does an equation look like? And you remember how fun this was the first time we did it?
Actually, I kind of enjoyed it.
Now guys, I'm giving you a huge gift. We need a slope and a y-intercept to describe this line. So what do you want to do first?
I found a slope.
The slope? So I recommend, because it's on a graph, counting the slope. Have you ever done that before? Okay, so I'm going to count the slope from here to here. You have to go down and then over. 1, 2, 3, 4, 5. Down 5, over 2. So that is my slope. What is the slope? Because I went down 5, it has to be -5 over 2.
-2.5.
So now we have to calculate the y-intercept. Well, what are you pointing at? Tell everybody else, please. He's like, but bro, the y-intercept is -3. Did you see that?
Yeah,
Is that going to happen on the test?
possibly.
Yes, it is.
Oh, okay.
It is. I'm going to give you the y-intercept. You just have to identify it. So what is the y-intercept?
-3.
Oh boy, we're having tsunami.
Cool.
Or snow.
No.
Who got kidnapped this time?
It's Carlos.
It was Baker.
Wait, what is that?
Amberlin.
It's an Amberlin.
It doesn't tell you natural phenomenon. It just tells you.
14-year-old white female.
Okay, you ready for that? Are you ready to get back into it?
Yup.
So, the equation of this line is -5 over 2 minus 3. Let's try it again. What? Okay, and I love that fact because it's applying multiple concepts to a midsegment. And that's what I'm throwing on your test. So if you know what a y-intercept is and you know how to count slope, it's not that bad. And what's even better is it's a freaking multiple choice question. Okay, so now what is the equation of the midsegment parallel to AB? So here is AB, and this is the one that's parallel to it. So we need two things. We need a slope and a y-intercept.
Is it gonna be 5?
Okay, so is the y-intercept the same?
Yeah.
Yes.
The y-intercept is right here. And now we just have to count the slope. From here to here. 1, 2, 3, 4, 5. I went up 5 and over.
I went the opposite.
You can't do that.
Oh, it says A, B, O.
You always go from left to right.
Should it be negative?
No, because it goes up 5 over 3. Look at the line. Is that a positive line or a negative line?
Yes.
Now, here's a super huge hack. It's a huge hack. Can I erase this?
Sure, whatever.
Okay, if this is the midsegment, right? What's the y-intercept? -3. Now, this midsegment has to be parallel to this side. So do you have to count this one? Can you just count this one? Up over 3. The slopes are the same, aren't they? Because they're parallel. But isn't this slope the same as this slope? So you can calculate the slope of this line or this line, it doesn't matter because they're the same slopes. But the y-intercept is what really sets those two apart. Alright, last one, because we haven't done it and it's worthwhile to do. That's the last line we haven't done.
The slope is
No,
oh,
the slope is 0.
I'm defining if it's a straight line.
But what's the y-intercept now?
Positive
So this is really just
2.
y equals 2.
You are acute. Oh, acute pi.
Narrow scale.
Narrow scalding
I
interaction.
got
I need to take a picture of that.
You're a cutie pie,
Narrow, scalding, and irrational.
and the cat says narrow, scalding, and irrational. Those are also synonyms for those pictograms that you see.
That's great.
Alright,